Hello everyone, my name is Prashant Mohan Thakur and welcome to Competition Valley. We are continuing with Factorial. This is class number 5 and most probably the last. If not the last, then most probably it will be the penultimate class for Factorial. So we'll be continuing with. So in this series, we'll be learning basically three things. We'll be learning some special numbers in Factorial. There are certain numbers which is pretty much special, I would say. Then there are numbers with special, I would say, character or feature. And then we'll see some special conditions. So the question would be around some conditions that would be given. Okay, so we'll start with special number and then we'll move ahead. Now there are only 4 such numbers in Factorial. I'll show you what I mean. 1 factorial, 2 factorial, 145 factorial and 4585 factorial. There are only these 4 numbers that would satisfy the condition what I'm writing away. 1 factorial is equal to 1, 2 factorial is equal to 2. Now see, 145 factorial can be written in form of summation of its digits. So if I say 1 factorial plus 4 factorial plus 5 factorial, it's going to be 1 plus 24 plus 120, which is 145 again. So there are only 4 numbers in entire Factorial wherein that the number itself can be written in form of summation of its summation of factorial of its digit. Over here 4 factorial plus 0 factorial plus 5 factorial plus 8 factorial plus 5 factorial. If we do it, it will be 40,585. So if you add it up, you are going to get 40,585. So these are special numbers, okay? And these are the only 4 special numbers that you have. So generally you don't get question, but you may get. So let's say if you have to do a question, we can do this way. And the question may say it's if a factorial plus b factorial plus c factorial plus d factorial plus e factorial is equal to a, b, c, d, e, f, where a, b, c, d, f is a 5-digit number, then find the number of trailing zeros in a, b, c, d, f. So as I said, there's only one 5-digit number that would satisfy the entire condition. What is that? 40,585. How is this going to happen? So we 4 factorial plus 0 factorial plus 5 factorial plus 8 factorial plus 5 factorial. Just check that. I'm just writing it cumulatively over here. If you want, you can do this way as well. 1 plus 120 plus 4 320 plus 120. So you will get this number. So what we have been asked, trailing zeros. So we know for trailing zeros, okay, 5 8 okay, and 5 8, then 5 1 17 16 80 1 1 2 7 5 5 3 1 2 5 6 2 5 13. So if you add it all, you will get the trailing zeros. Add it, don't skip it, okay? Add it. I don't need to add, but you can add it, and don't use calculator. Try to do it on your own, okay? So this is one question. So that's how it is. You can understand this concept. Now we'll do another concept. Now we'll do the second part, number with special features. Okay, so we'll see some numbers in Factorial and how do they play out. Okay, so for the first one is 11. The first one would be 11 factorial. See, generally what happens, let's say you can take what is 11? 11 is a number with 2 similar digits. So if you take any other 2 similar digit number, like you can say you can take 33. So if you multiply 3 into 3 and if you add 3 by 3, so always multiplication would be higher. Okay, what I mean to say is if it's a similar number, let's say a is a similar number, let's say the a is the number, so a into a would always be greater than a plus a. This is known fact. but 11 is an exception. This is the only number with two similar digits where multiplication of its, or you can say factorial of multiplication of its digits is less than the addition of its digits. How is it? So in 11 factorial, if I multiply 1 into 1 and I add 1 into 1, so always 1 plus 1 would be higher. Just see what I've written over here. 11 is the only number with two similar digits. Okay, remember, two similar digits with where multiplication, we have multiplied it, but even after multiplying it is coming lesser than the summation. It's very simple concept. Okay, I'll tell you later on, but let's just stick to this over here. We'll teach about it like in next concept. Okay, so this is one. Now we'll do the second concept. Now 22 is yet another number with two similar digits. So 22 is the only number with two similar digits where sum of factorials of its digits is equal to multiplication of factorial of its digits. So 2 factorial into 2 factorial is equal to 2 factorial plus 2 factorial. We're getting 4 and 4. This is the only number. So this was the second thing that we had to learn. There are certain numbers with certain extra characteristics. We'll see how we can use them in coming questions, and then we'll take a concept out of the 11 factorial that we did. Okay, so now we'll go for the third, which was certain conditions. The question, this condition will be learning with some questions. Okay, that way we can understand the concept. So it says n is a 2-digit number. Okay, so it's a 2-digit number. Let's say n is AB. There's the product of factorial of it. Product of factorials. It's not just the product of 2 digit. Okay, it's product of factorial of its digit. So 1 into this is greater than the sum. Okay, now understand this. This is very good concept. Okay, so it says that the product of factorial of its digit is greater than the sum of factorial of its digit. Okay, so how would be doing it? Now, can you think of any two numbers? Think of any two numbers wherein if we multiply the number, okay, the factorials of it, and if we add the factorials of that number's digit, the multiplication would be higher. You know, you can check for, let's say check for 14. If you check for 14, so what's happening? 1 into 4 factorial and 1 plus 4 factorial. So we see that this is not satisfying the condition. This is going other way. This is greater because this is 25 and this is 24. You can check for any other number. You can, let's say we can check for 19. If you check for 19, so 1 into 19, okay, and then you have 1 plus 9. That's how it's going to happen. So anyhow, you see this is 9 and this is 10, so still it would be greater. Okay, so it is not satisfying the condition. So what should we do to find a solution for this? See, now understand the concept. Let's say we have two numbers equal. So let's say 5 and 5. Okay, now if we are multiplying 5 into 1, this is 5, we are multiplying this with 1, so it remains the 5. But if you're adding 1 to the 5, it becomes 6, isn't it? So this is going greater. So what's happening? If the numbers are same and we are adding and multiplying 1 to that particular number, then the addition would be higher, multiplication would be lesser. Over here, we need to find that something wherein multiplication should be higher. But what is the general rule that we're finding? See, if we do 7 into 1 and if we do 7 plus 1, certainly 7 plus 1 is going to be higher. provided 7 and 7 are the same. It is true for all the numbers. If the numbers are same and you are doing some operations with 1 wherein you are multiplying and you are then adding, so if you are adding it, then it will be always be higher than the multiplication. So what we need to do is this: we don't want it, we want this section to be there, so we got to omit all the numbers that contain 1. Similarly, 0 factorial is 1, so we got to omit all those numbers that contain 0 factorial as well, isn't it? Now we have certain exceptional numbers that we studied about. So 11 is certainly one of them, and 22. Why 22? Because it says n specially says it should not be equal. It says a into b is greater than a plus b. But in 22, what did we study? It's not greater, it's equal to. So we got to omit this as well. So what are we going to omit? So first, how many number do we know that it's a 2-digit number? So there are 90 such numbers which is 2-digit number. Out of 90, what are we going to omit? We have to omit all the numbers from 10 to 20, 10 to 22. So it will be 13 digits. And what are we omitting? 10 to 22 minus we are omitting all the numbers which has 0. So 10, 20, 30. So we have already taken 10 and 20. So we are omitting from 30 to 90 minus, what are we omitting? All the numbers that have 1, like 11, 21, 31, 41, 51. But again, we already have taken 11 over here and we have already taken 21 over here. So we are doing what? 31 to 91. So what are we doing then? 90 minus 27, which is giving us 63. See, beautiful, beautiful, beautiful question, isn't it? All your concept will be applied over here. Why we did that? Because simple. Anywhere if it is 1, it's not going to satisfy it, because if the numbers are same and you are adding 1 and you are multiplying 1, always addition would be higher. But we don't want here. We want the addition to be on our other end. So what we have done, we have omitted those things, and that's why you have 63. Okay, we'll do another question. Just if you want, you can observe it in the meantime. So you have this question over here. You can read it in the meantime. It says, how many 2-digit numbers less than equal to 40? So we have 2-digit number which is less than or equal to 40. Have the product of the factorials, a factorial into b factorial, of their digits less than the summation. Now over here, see, it's a reverse. Earlier what we had that the product is higher. In this question we have product as the lower. Okay, so again, simple. It's very simple now, because what we know that whenever you have in such section, if you have 0, if you have 1, then this is very certain that multiplication would be small. So if it's a 2-digit number, I can say 10. So 10 to 21 I can say. Now we cannot take 22. Okay, so 10 to, because it still does not say it's equal to, so we are not going to take 22. So 10 to 21, then what? Then you can say 30, 31, and you take 40. You cannot take 41 because it is limited only to 40. So 10 to 21 is what? 12, and then 13. 12, 13, 14, 15. Yeah, so it's 10 to 12, and so if we count it together, it's going to be 15. That's the answer. Okay, so it's a 2-digit number less than equal to 40. Okay, that's what we have done. Simple concept. What were you trying to do over here? If a into b, let's say 7 into 1 or 7 plus 1. So we know 7 plus would be always good. So 7 into 0 factorial into 7 plus 0 factorial. So 7 into 0 factorial is 0, 7 into 1 factorial is 8. So this is always true. Okay, for 1 and 0 it will be always true. But why we cannot take 22? We cannot take 22 because we know that in 22 the sum and the multiplication is 2 factorial into 2 factorial is equal to 2 factorial plus 2 factorial. But we don't have equal over here. That's why we are not taking 22. So we are omitting. So we are taking 10 to 21, which is 12 plus 13 plus 14 plus 15. Okay, I'll do another one. So again, the question is same. Little it's equal to 15 now. So how many 2-digit number? 2-digit number less than or equal to 50 are the product, wherein product of factorial is less than sum. So we know what all we can take. All those number less than 50 that carries 0. All those numbers that carry 1, we can take that. we cannot take 22. We know it why. Okay, so we can just take 10 to 21, then we can take 30, 31, 40, 41 and 50. So it will be 11 plus 1, 12, 13, 14, 15, 16, 17. Simple. Okay, it's very simple concept. If you understand concept, you can do it. It won't take any time for you to do that. So we have learned all these things, whatever we intended to learn in this video. So we learned about, we'll just do a quick recap. So we learned about the special numbers in factorial that has special features like 1, 2, 145 and 40,585 factorial. Okay, because they, if you add the digits of these numbers, they will form the number itself. Then we've learned about 11 factorial and 22 factorial. This is the only number with similar digits wherein the multiplication is lesser than addition, and this is the only number where multiplication and summation are equal. We learned about that, and then we learned about some condition wherein a product of factorials of digits is greater than the summation, and then the product of factorials of digit is lesser than the summation. These are the three things that we intended to learn, so we did that. So we are stopping over here. We'll do one more video because it has three unusual concepts, I would say, so we should not mix it over here. We'll do that. So till the time, enjoy the class, revise the maximum you can revise it, and remember, I would never miss any topic that would be in the examination. So you can fully rely upon me and just revise it and leave everything upon me. Okay, so once again, this was Prashant, Mohan, Thakur from Competition Valley, and we'll meet soon in our next video. Thank you.